Network Rail have developed a high-speed clamping system with Robel and ALR, known as HSCS, that temporarily connects both new rail to new rail and new rail to worn rail, allowing trains to run at 100 miles per hour without imposing temporary speed restrictions. The HSCS can be used on SEN 56 and SEN 60. However, there are some restrictions with SEN 60, as lift plates and cutouts are not currently available. The system can be used on bidirectional lines, providing there is a flat running surface in both directions with no step at all. The system cannot be used in single-bore tunnels. A poorly fitted rail joint running at 100 miles per hour could be subjected to forces 10 times that of a rail joint running at 50 miles per hour. A step-up of only 2 mm will increase these vertical forces by a factor of 3. There are significant consequences to the safe passage of trains if the plates and clamps are not installed and correctly inspected in accordance with the mandatory procedure. However, when the system is correctly installed and closely monitored, it presents a reduced level of risk. This media demonstrates how to correctly install and monitor the high-speed clamping system. Plates and clamps must only be installed by authorised persons, briefed and approved by the TME. Once the installation is completed, the complete arrangement should be inspected by a certified checker TR11, competent to 100 miles per hour. Prior to fitting the high-speed clamp system, it is necessary to visit and scope the site for rail defect replacement, to ensure it is suitable for installation of the high-speed plates and clamps. The specific on-site checks you will need to do are: first, check the rail section and headwear to identify the correct lift plate required. The aim is to install the clamp with no step-up. Check that it is not a tight radius track with a radius less than 300 meters. Check the sleeper condition and check for any voiding. The high-speed clamping system should only be installed on a firm bed. Any voiding will need packing during the installation process. Check that there are no wet beds. And finally, check that 2 sleepers either side of the joint are of the same type and not at more than 700 mm spacing, otherwise the clamps will not fit. Complete this information on TEF 3252 and fill in the site diagram to give to the installer for the shift. On the night, you will need 1 pair of high-speed lift plates as decided by the scoping visit and a pair of the next size lift plates, 4 Robel Type 9 temporary rail clamps, an adjustment ratchet spanner with a 41 mm socket, short-handled copper mallet, long-handled copper mallet, 4 void meters, 1 thermometer, appropriate equipment to pack the joint, rail jack if lifting the rail more than 2 mm, torque wrench set at 400 Nm, wire brush, tape measure, 2 step gauges, pan puller, straight edge, temporary earthing strap, headwear gauge, iPhone or iPad with photo reporter app, access to 20 miles per hour, 50 and 100 miles per hour speed boards, and an emergency speed restriction design as a contingency measure. TEF 3252. Also, plan a safe system of work pack so the installation can be checked after the second train has passed over the joint. Check kit list and all the equipment necessary to perform the installation. Carefully examine the fishing surfaces of plates for any burrs. Also check the plates are straight and not damaged and distorted. Lubricate and unscrew the clamp nuts half off the thread and loosely secure the locking plate in the unlocked position. Load vehicle safely and securely and transfer to site. Remove defective rail and begin completing TEF 3252 using it as a prompt. A site diagram should have been completed during the scoping visit. This helps to ensure you are not mixing up left-hand, right-hand, low or high mileages. Also, mark up the direction of travel. Sharply hit existing rails to ensure that any residual stress is released. Dig out 3 beds where clamps will be located. Install new closure rail against the disc cut joint, carefully measuring and butting up to the existing rail. If one end is being welded, it is always preferable to weld the run-on and fit the HSCS to the run-off end. Record the rail temperature and installation time, and use a headwear gauge to confirm rail wear from the scoping visit so that correct lift plates may be used. Ensure all 4 clips are removed. Use the wire brush to clean the area, ensuring a good contact between the plates and the rail. Fit the plates in the centre of the beds, matching the centerline with the joint. Run your thumb along the top surface of the plate to check it's the correct way up and that the arrow is central to the joint. Place a step gauge vertically at the centre of the plates on either side of the rail, as illustrated. Use your thumbs to feel the gap between the end of the stepped gauge and the rail foot. When this gap is equal on both sides, the plates will be vertical. Loosely fit one clamp in the centre to retain plates in position, using the short spanner and copper mallet as appropriate. Ensure that the bolts of the clamp are all fitted in the forefoot. Tap in nylons. And use a pan puller to install clips. E-clips often fit better than Pandrol PR clips, but these shouldn't be used with base plates or grey cast iron plates. If instead you are using fast clips, they will not fully engage, but they will still hold the rail adequately. Loosely fit the remaining Robel clamps and tap all clamps tight up against the sleeper edge. If you're fitting lift plates of 2 mm or greater, jack up the worn rail until level before bedding in plates. Tighten the clamps and hit the plate repeatedly through its entire length with a copper mallet. The clamps should be tightened in the correct order: 2, 3, 1, 4. The plates, and not clamps, should be struck hard with a copper mallet to ensure these bed in well. This is very important, and so the cycle of tap and tighten 2, 3, 1, 4 will need repeating several times until the clamp bolts can only just be turned. The plates must be visually checked to ensure it is fitting snug into the rail. Check that a minimum of 400 Nm has been achieved with a torque wrench. Over-tightening if necessary, since the locking plates only engage every 60 degrees of turn. The running table should ideally be level. Use a straight edge to check, but make certain that there is no step up. However, a running off ramp of up to 2 mm is allowable but undesirable. If you are unable to remove any step up or 2 mm ramp off, then impose a 20 mph speed limit as per standard fish-plated rail joint. Measure and record rail gap. The gap must not exceed 10 mm, otherwise a 20 mph speed restriction should be imposed. Also check for sideware, which may need matching by grinding. Fit the cribs with ballast. Thoroughly consolidate ballast with vertical tampers, or an appropriate track geometry repair method. Ensure that a minimum of 2 sleepers either side of the joint are packed. If more than 2 mm lifts have been used, then you must pack an additional sleeper on the worn rail side for every millimetre lift. For example, using 5 mm plates requires 2 sleepers packed on new rail and 5 sleepers packed on worn rail, where it has been lifted 5 mm up out of the ballast at the joint. Any voiding should be eliminated. Voiding in excess of 5 mm must be packed. In addition, if the other end of the rail was welded, it must also be packed to eliminate any voiding. Fit 4 void meters, ensuring the feet sit on well-packed, flat ballast. Otherwise, they will show more movement than the rail actually deflects. Fit temporary bonding and test track circuit if appropriate. Arrange the lighting if required, copper mallet and torque wrench, then use the Photo Reporter app to advise the line manager, HSCS reliability mailbox, and TME that the work is completed. The Photo app provides a record of installation, and the photo should be taken by the certified checker with a date and location stamp prior to opening to traffic. Ensure all the TEF Form 3252 is complete and signed off by installer and checker. ClearSight. A competent certified checker with TR11 competence to 100 miles per hour must return to inspect with an appropriate safe system of work to view performance of HSCS under live traffic. The joint at the HSCS must be watched under traffic after at least 2 trains have passed over, but no longer than 6 hours after the first train. If there are any concerns at all, the bolt torque should be checked with a torque gauge to ensure that the plates have not settled or the clamps worked loose. This can nearly always be heard by listening to train wheels passing over the joint. Rail gap and voids should be measured and recorded on the form and signed off by the competent certified checker, with another photo reporter advice sent to all, confirming safe to run at line speed. If there are any voids or the rail gap is growing, then this will need packing and a follow-up inspection later the same day. If there is any doubt about the integrity of the joint, then a 50 miles per hour speed restriction should be imposed, or a 20 mile per hour speed if the gap exceeds 10 millimeters. The HSCS must be inspected every 24 hours by the competent certified checker with TR11 competence, with sign-off and photo reporter until removed. A 20 miles per hour speed limit should be imposed if duration exceeds 7 days, unless agreed otherwise by the Ramtrack. When the HSCS is finally removed, complete TEF 3252 and return it to your line manager. The HSCS is a very effective temporary clamping system, but it's essential that the system is correctly installed before being approved for traffic.